Hello and welcome to Mr. Tompkins Ed Tech. This series of videos is based on the advanced information released by the exam boards ready for the 2022 GCSE exam papers. This advanced information gives detailed information about what will be appearing on each of the 3 papers and will help you focus your revision on the topics that will definitely be coming up. Now, you can find all this material yourself on the exam board websites, which I'll link for you below. It's freely available and can be downloaded by anyone. So why do you need to watch this video when you could just go read that instead? Well, for those of you not simply horrified by the words read it yourself, the information provided by the board is aimed at exam centres and is actually not very student friendly. It requires a bit of interpretation and knowledge of the syllabus. So in these videos I'll be summarising this information for you, telling you exactly what topics you need to be revising for each paper. I'll also be drawing on my experience of previous papers to give you my best guess for the type of questions you might expect. I think it will be well worth your time watching it all the way through. Below the video I'll provide links to example exam questions and compilations on each of the topics mentioned to help you get on top of any areas that you are not confident with. I've also created a playlist of these question compilations for each specific exam paper to help you focus your revision prior to each exam. There may be a few gaps currently, but I'll be working to fill those in between now and the exams. So if you're not yet subscribed, why not do that now and hit the bell so you'll be notified when these and other resources are uploaded. Now, if you find this video helpful, please do give it a like. This really helps me out. Also, why not share the video with your teacher and your friends, as I'm sure they will also find it useful. Let's get into it. Welcome along to this first video review of the advanced information made available by OCR. We're going to be looking at paper 4 today, which is the first calculator paper from the higher tier. Just a reminder of how to use this video. Watch the video through first. I'm going to go run through every topic that's going to come up on the paper. Once I've done that, below the video you'll find a whole bunch of links to example questions matching up with those topics. So these are my best guess of the type of question that is going to come up. Very worthwhile going through each of those. Finally, I've included quite a big playlist of topics that I've identified with lots of extra questions. These to give you a bit more extra practice of those topics. So if you're struggling on a particular one, then definitely worth jumping through that and reviewing that material. Okay, so let's get cracking on this then. So the advanced information is broken down into the 6 mathematical strands: number, ratio, algebra, geometry, probability and statistics. And I'm going to go through each one and identify the topics and talk a little bit about them. First up, number. And the first topic identified is calculator use quotients. So can you use your calculator accurately? If I give you a really complicated piece of arithmetic shown as a quotient, so things on the top and the line and more things on the bottom, can you type that accurately into your calculator and come up with the correct answer? If you can, no worries, let's move on. Priority of operations, presumably that is bid mass, knowing the order that you're meant to do things. It might also refer to kind of these longer problems where you've got multiple things that you need to add, multiply, divide, and you have to kind of work out the order that you need to do it in to get the right answer. Percentage calculations, finding the percentage of a number, doing a percentage increase, something like that. We've got percentage change identified specifically, which is if I give you a before and after price, can you work out what the percentage increase or decrease has been? Reverse percentages, so if I give you a final price, can you work out what it was to start with from before the percentage change was made? Upper and lower bounds, this is sometimes referred to as error intervals or limits of accuracy. So it's where a number has been rounded to a certain degree of accuracy, like to 1 decimal place, and you need to then consider the range of possible values it could have been that it got rounded to that number. And often there are additional questions where you have to pick which bound to use to come up with the right answer. A standard form representation, so writing it as a number between 1 and 10 times 10 to the power of something. It doesn't specifically mention calculations with standard form here. It does in the next paper, so presumably it's just writing things in standard form in this paper. But you need to know the rest of it for the other papers. Decimal fractions, percentage equivalents. So can you convert between a decimal to a fraction to a percentage? Yeah, those skills could crop up throughout the paper on multiple questions. Right, moving on. Ratio, direct proportion. So if y is directly proportional to x or x squared, can you work out the equation that links y and x? Okay, often you're given a pair of values that go together to find the constant of proportionality and come up with the entire equation then. Solve ratio and proportion problems. There's a whole myriad of these, and I know students often find them confusing. I do have a video of a kind of a compilation of ratio questions that, if this is an area that you struggle with, well worth you going to watch that. Growth and decay problems. Now, these I would consider these like a percentage question. They're like compound interest really, but applied to things that aren't interest. Yeah, I'll include an example sort of question that's come up in the past from OCR. Onto algebra, factorizing quadratic expressions. So taking a quadratic ax squared plus bx plus c and putting it into two brackets. And then you've got multiplying out brackets. It doesn't mention if that's single or double. It's not going to be triple. They would probably mention if that was the fact. Algebraic fractions. So add in algebraic fractions, simplifying algebraic fractions. Okay, but they work the same way as normal fractions, but I know that students do struggle with this. Again, if that's an area of you that you need to work on, I do have a kind of a big video with lots and lots of examples. Substituting values into expressions. So if you've got like a formula and you know the values of the things inside, subbing those in and working out the answer. Formulating algebraic expressions. Now these tend to be worded problems or maybe geometric, like you're given a rectangle with algebraic sides, and you need to find the perimeter, those sort of things. So you have to kind of form an expression, and then often you then also need to go on to solve it. Use of brackets. Well, we've already talked about multiplying out brackets, so presumably this is, if you are formulating an algebraic expression that requires brackets, so you put them in the right place. Now, note that these lists of things, there are more things identified here than there are going to be questions on the paper. So some of these things are like parts of another problem. So I think use of brackets is not likely to be a problem by itself. It will feature as an element of another question. Solving inequalities. Well, inequalities solve very much the same way as equations. It doesn't mention drawing them on number lines, but that's a possibility. Drawing and interpreting graphs. So you should be able to draw linear graphs, quadratics, cubics, reciprocals, and what's the other one? Oh yeah, exponentials. So yeah, could be any one of those. It does specifically mention quadratic graphs here, so they're the parabola-shaped ones, aren't they? You might have to go on and find roots. You might have to go on to identify turning points, things like that. Equations of circles. So x squared plus y squared equals r squared is a circle-centered origin, isn't it? So knowing that, being able to take the equation, draw the graph, identify the equation, that sort of thing. And then finally, algebraic proofs. So they're the sort of questions that say, like given or show that two consecutive numbers added together is always odd, those sort of questions. Where, yeah, you have to kind of come up with some algebraic values and then do some arithmetic with them and come up with a conclusion. Okay, right. Next up, geometry. Properties of a triangle. Now, a triangle, well, presumably angles of a triangle add up to 180, but also different types of triangle and their specific properties. Like you've got scalenes, isometric triangles where the base angles are equal, and you've also got equilateral triangles. So they might be in a more complicated diagram. So I noticed further down the list there's some other angle things that you need to know about. So triangles might feature in a more complicated angles diagram. Circle terms. So knowing about what's a sector, what's a segment, what's a radius, what's a circumference, what's a chord. Be able to label them a diagram. Angles in polygons. So knowing that the sum of the interior angles of a polygon is equal to n minus 2 times 180, and knowing that the exterior angles always add up to 360, finding particular angles in regular polygons. Properties of parallel lines. Can you recognize corresponding alternate and interior angles of parallel lines? and use those facts to work out angles in diagrams. Again, this might feature the triangle that we talked about before. Units of length and time, so converting between hours and minutes, or converting between centimeters and millimeters, that sort of question. Compound units, rates, not sure what rates refers to. It might be work rate. So, you know, if 5 people can do a job in 10 hours, how long does it take 2 people? That sort of thing. Volumes of pyramid and sphere. If this is like one question, then they tend to, you know, you'll be given the formula for pyramid and sphere. So pyramid, 1/3 area of the base times its height, sphere, 4/3 pi r cubed, but you're normally given those in the test. If they're coming together, maybe you have to work out the volume of one. They might say it's equal to the other one, and you might have to then work backwards to find a height or a radius. Something like that tends to be quite a typical thing. I don't think there'll be 2 separate volume questions, so it'll be one question that features both, and maybe they're linked together in some way. Standard circle theorems. So standard being that you don't have to prove anything, I suppose. You just have to kind of work around your diagram. Now again, you know, there's triangles and parallel lines mentioned as well. So it could be that they're all part of one problem. And so, you know, I don't know. But knowing, you know, your 4 or 5 different circle theorems that you need to know about. Circumference of a circle. Well, it's pi d, isn't it? Should know that one. And finally, Pythagoras theorem. Now, interestingly, Pythagoras theorem is not on the foundation paper, so presumably this Pythagoras theorem question is not going to be one of the super easy, straightforward ones. So, yeah, just be aware of that. It might be a harder one. It might be in 3D, or it might be like one where you have to use it twice or with other things. Okay, next strand, probability. First up, enumeration. Enumeration just means evaluating, doesn't it? Coming up with a numerical answer to. So presumably, you know, working out some simple probabilities and expressing them as a fraction. Calculation with the laws of probability. Well, I assume the laws of probability apply to rules like probability of A and B, probability of A or B, and how you then combine those different probabilities together. That's what I assume that's about. And then finally it says conditional probability. Now, conditional probability is where you work out the probability of something happening given that something else has already happened. Now, there is a formula identified on the formula sheet on how to do that, but often I think that's like overkill, and it's easier just to kind of figure it out from the diagram or the question itself, especially if it's on a Venn diagram. But anyway, there's strategies for dealing with that. I'll put some examples below. Finally, statistics, collecting data. So taking data and putting it into a group frequency table, something like that. Now, I've linked to a question below. It's actually a part of a larger question. There's 2 parts to it. The first one is collecting data, and the second part is histograms. Now, histograms are definitely not featuring on any of the papers, so which is probably a relief from some of you, because I know that some of you find it quite hard. So where I link to the collecting data question below is really just the first part of the question that you need to look at. Skip happily over the histogram. Finally, scatter diagrams and outliers. Well, scatter diagrams, that you don't tend to have to draw the whole thing, but sometimes they give you a couple of points to add to a kind of semi-complete scatter diagram that's already in the paper. You might have to draw a line of best fit on it. You might have to mention what you think the correlation is. Is it positive? Is it negative? Is it strong? Is it weak? You might have to use the line of best fit as to look values up, like it's called interpolation, isn't it? Where you kind of look up to the graph and across and read off values where you know one and not the other. I did look through all the other previous questions from OCR, and I couldn't actually find any which asked you to identify outliers, so I couldn't find a good example of that happening. But outliers essentially are the ones that don't fit the pattern. So, you know, you'll find that most of your points are hugging your line of best fit quite closely, and you've got like one ridiculously far away point. That will be the outlier. And that's everything on the paper. So huzzah, that's, if you know all those things, you're going to be golden. Don't forget to go through the example questions linked below, just one after the other. You can press Control, click on it, so it opens up in a new list rather than having to keep coming back to this video or whatever. I'll try to get the other papers out soon. Good luck in your preparation. I hope it all goes well. See you on the next video. Don't forget that the best revision for these exams is to go through all the past papers from previous years. The advanced information really doesn't change that. Here's a link to all the past paper walkthroughs I've done. There's a link below each video where you can download the paper. If you work through all of those before your final exams, there will be really few surprises for you on the day. Good luck and see you on the next video.